All right. Hey, everybody.
Hi, everyone. Can everyone hear us okay? Sweet. This talk is called The Path Less Traveled, Abusing Kubernetes Defaults, and it is going to be demonstrating to you some interesting things that can happen with a Kubernetes cluster set up out of the box. So let's get to it. My name is Ian Coldwater. I am a lead platform security engineer at Heroku. Before that, I was an independent penetration testing consultant specializing in hacking and hardening Kubernetes containers and cloud infrastructure.
My name is Duffie Cooley. I'm a staff cloud native architect at VMware. I came there as part of the Heptio acquisition. I've been working on Kubernetes since about 2016, just jumping into the community channel and helping everybody that I can. I'm also a co-host of TGIK.io. If you're interested in the space around Kubernetes or pretty much anything in the cloud native ecosystem, I highly recommend that. We do it every Friday at 1 o'clock, so check it out.
So the first thing we want to say is check your assumptions. A lot of people, maybe not necessarily other people in this room, but a lot of people assume that Kubernetes is secure by default. And it's not. Kubernetes by design is designed for granular control. So the defaults are actually quite open and allow for you to be able to customize your cluster according to your needs and your use case. And that's not bad, but it isn't secure out of the box. And neither are the applications deployed upon it. So let's break that down a little bit. For one thing, it's a little bit of a misnomer to talk about Kubernetes defaults, because there is no singular set of Kubernetes defaults. All of the distributions have slightly different defaults out of the box, and every cluster is going to be slightly different according to what kinds of configurations, plugins, and other things you have running in it. So it's a little hard to give one-size-fits-all security advice, either on attack or on defense. But there are a lot of commonalities, and so we're going to talk about those today.
This talk uses a cluster that's actually, uses defaults as defined by kubeadm. kubeadm is a project that is actually meant to provide common tooling that gets you from the place where you have infrastructure up to the point where you have Kubernetes. And the benefit of having that common tooling is that we can extend that. We have a single place where we can kind of extend what those rational defaults are, right? We provide a good configurable surface, and we also provide kind of a better set of defaults for getting you from a place where you have infrastructure to Kubernetes.
It's important to note here that kubeadm actually is designed for having relatively sane defaults. And so this is the thing that we're going to be exploiting out of the box today. Many kinds of configurations or like installers will actually have defaults that are weaker. And that's important to note. It's also important to note that Kubernetes by default overrides Docker's default seccomp profiles and the security position that Docker sets up by default. A lot of people assume that that's inherited, and it's not. It's actually overridden to avoid breaking changes. So we wanted to point that out because it's important. What do we mean when we're talking about Kubernetes here? Presumably, if you're at KubeCon, you have a general idea that Kubernetes is a container orchestrator, that it does all these things. But for the purposes of talking about it as an attack surface, Kubernetes is two different things. It is both an application and its associated set of binaries, and it is like a loosely coupled distributed system, and it's an API platform defined by YAML. So it's both, and both of those are attack surfaces, but they're not necessarily the same attack surface. So we're going to cover that as a whole today. So anybody want to attack some stuff? Let's attack some stuff. Let's get into it. So what's going on here?
All right. So this first session, what I'm going to use, for this first demonstration, we're going to talk about a tool that I wrote that helps me diagnose or debug what's happening with etcd if there's actually a problem. So what this tool does is it basically is just a static pod or a pod that you can actually deploy as a deployable pod. And it's going to grab the etcd binary that is actually being used within the cluster, so just a version of etcd. I set some environment variables, and I'm making use of host path here to be able to pull in all of the certificates necessary to allow etcd client to authenticate to the etcd cluster that is hosted inside of the system. I'm actually targeting localhost here to connect to it, and to that end, I actually need to make sure that this pod is running in the host network so that I can actually provide that access. Once I get this deployed, I'll be able to use it to diagnose things. So one of the things I might do is just do a member list or a member status just to understand the current state of that etcd cluster.
So that's a legitimate use case for a sysadmin or somebody who's trying to debug a cluster. But what else could you do with a list of members and their associated permissions? Let's find out. So I'm dumping all of the secrets from this etcd, and that's interesting. What do we have here? We have various kinds of things under kube system namespace. One of the things we have is called cluster role aggregation controller. This has been patched as of 1.16, but in previous versions, it still works. Cluster role aggregation controller, because its role is literally to aggregate cluster roles, has access to everything. It has administrative control over the cluster by default. So that one looks interesting. Let's see if we can get a token out of it. As it turns out, yes, we can. So with this token, let's see what kind of permissions we've got on it. kubectl auth cani --list, which is the best tool for pen testers that's come out in years, as far as I'm concerned, handily enumerates all of the possible permissions that we have. So we can figure out exactly what we can do with this token in a very neat automated fashion. Previously, when we were pen testing a cluster, we would have to do every single call individually to figure out what kinds of permissions we had, and that was annoying and took a long time. So thanks, Kubernetes, for helping our enumeration process. So what kinds of access does this have? Well, as it turns out, one of the things it has is wildcard, which that seems like that could be potentially useful. So with our lovely cluster role aggregation controller wildcard, we will now take over not only this cluster, but the underlying node, because we have mounted it on host path, and it's mine, game over, I get to go home, too bad. So there's that. One of the things we're going to keep talking about here is how a lot of the time things that are very useful debugging things for sysadmins, for example, or like legitimate use cases for somebody who is like trying to operate a cluster can be used exactly the same way, but for nefarious purposes by somebody who is maybe up to something else. So that's an important thing to be able to think about, and this is what my keynote on Thursday is about. So we directly scheduled that, that on the underlying node because the kubelet was running in the same node, and that is problematic because if you run a kubelet on your control plane node, if you take over the underlying node, there you go. Okay, so what can we take away from this demo? For one thing, if you're authorized to create pods, you can do a hell of a lot by default because it just allows you to.
That's right. We can also, and to your point, scheduling is not a security boundary. You can directly schedule any pod that you want. Namespace isolation, especially in the absence of admission control, is not enough isolation, right? If you have the ability to make use of host path, it's very scary. It's not, and the mitigations that we can do, in our example, we were showing the ability just to grab the plain text as it was stored in etcd. If you were encrypting etcd at rest, especially in the secrets, then that output would have been encrypted output, and it would have been much better to view. Like.
Worse for me. So, okay, yeah. Make sure that you are applying appropriate forms of isolation and don't assume, again, check your assumptions that any one of them is going to be enough. So we've mentioned host path a couple of times, and I wanted to talk more about it because host path is wild. Host path is so wild that we named this talk after it. Host path is defined to this day, you can look at it on the site, this is a screenshot from it, in the Kubernetes documentation as a powerful escape hatch. They are not kidding. It is an incredible powerful escape hatch. You can escape all kinds of things with it. Host path has legitimate use cases and is used fairly commonly in a couple of use cases that we'll talk about in a second. But it is so powerful and so ripe for abuse that it's really important to understand that so that you can protect against how easy and how powerful a path it is for an attacker. One potential use case for host path is
Docker and Docker. So Docker and Docker, actually there's a couple of different definitions for Docker and Docker out there. And in this next session, we're going to show you how the definition in which you expose the Docker socket of the underlying host up into the container by leveraging host path. The problem isn't actually specific to Docker. All of the container runtimes that I'm aware of all have the same setup, I should say.
So people use Docker and Docker a lot. But it's important to know that exposing the Docker socket allows users who have access to the Docker group pretty much root access on the host, and like immediately. Like an exposed Docker socket as a pen tester means that literally by the time I'm done pushing the K-cup button, I've got root and I can go home. So all of the container runtimes, as Duffie said, have this kinds of socket, and it's really important to know that like giving users access to this socket, even if you are running them as non-root, as non-privileged, actually gives them root access to the underlying host. It's important to know that, because even if you are setting up things that aren't privileged, they can escalate the privileges remarkably easily. We're going to demonstrate this. Let's talk about it.
So in this part of it, we're going to show a Docker and Docker example here, and we're going to show exactly why it is kind of a scary thing. So in this, this is a pod manifest that I'm going to use to express this, and you can see that I'm doing a lot of the reasonable security things. I've got a setconf profile defined, leveraging the Docker default. I'm running as not root within the context of the container. And the interesting thing about this security context is I can actually fill in these numbers however I want. And when the container starts up, it will be operating as that user, as that group that's being defined. We're going to get more into why that's interesting in just a minute. But the other thing I'm doing is I'm going and I'm mounting in that var run Docker socket, and I'm again specifying that node name. So this again is, I could turn the scheduler and the controller manager off and still operate this pod. Right? This is a loosely coupled system within Kubernetes. So because I'm actually fully defining the pod, I can do anything here. So if I go ahead and apply this.
And this is a pretty well secured setup in theory, except.
So we can see that when I jump in here and I type ID, I'm running as that user in that group that we saw before. And the reason I picked that particular GID is because in this install of Docker, as with most installs of Docker, there's going to be a Docker group that's been defined, right? And the group ID for this particular install was 132. So I just specified that in my pod spec so that I could actually go ahead and impersonate someone in that group inside of the context of the container. So with this setup, I can do things like build and push images, which is kind of the key use case for a Docker and Docker implementation. And I can go ahead and start things. So if I exec into that container, I can run a command like docker run nginx and point it to a particular image, and it will go ahead and start up. But because I actually targeted a specific node, I actually targeted my laptop here. And if I do docker ps on the underlying node, my laptop, I can see that image that was created. And we know it's the same one because it was started 19 seconds ago. This is the image that I started within the context of that unprivileged container, right? So this is an example of some of the power of that capability.
The other kind of power of this capability, though, is that it allows us to get pretty much immediate root access to the underlying node. So we can also take over the host with it, as it turns out.
So in this example, I'm going to go ahead and create a file inside of the etcd directory. And you can see that to create this file, I have to have sudo access because I'm just running as a normal user. But I can actually use that same access to go ahead and remove this file just by running a container within the context of that Docker and Docker socket. Right? So if you're running Docker and Docker, you have the underlying host. You could do pretty much anything to that underlying file system because everything that you express against that Docker API inside the container contextually is represented by the underlying host stuff. So if I mount in a volume like etcd or like the /etc directory, for example, that's the underlying host's etc directory. It's not the one that's actually expressed inside of the container because that Docker socket is running on the underlying host. This is why this particular form of Docker and Docker is a terrible idea.
And as an attacker, if I'm able to do whatever I can dream up, there's a lot I can do there, because as an attacker, I have a pretty good imagination, and there's a lot I can dream up. That's not necessarily the kind of access you want to give. So, what can we take away from this demo? Docker and Docker gives a lot of access to the underlying host by default, like a lot, like root. And it allows an attacker or a legitimate admin to gain full access to the kernel when used in that way. So it's really important to be careful when you're using it, be careful about what you're exposing, and be careful about how you're working that out. So how can we fix that?
Say that again, sorry.
So you can mitigate that by restricting the use of host path with admission control, which is a thing that you can do in a pod security policy.
Yeah, and it's actually very granular. Like that being able to mitigate that, you can actually whitelist specific paths that you can expose to a container. So it's pretty neat.
But leaving it open by default can leave you vulnerable.
Yeah.
So When we were talking about that, that wasn't Kubernetes specific, you might have noticed. That was a Docker attack. Because Kubernetes is a container orchestrator, attacks on containers are still viable. You can still do them. And it's important to know that because if we understand how to attack containers, we can understand better how to attack Kubernetes. And if we understand how to attack Linux, we can understand better how to attack containers. And also how to secure them. Because containers aren't magic. They're just Linux. And if you understand the low levels, it can help you both be able to understand if you understand how they work, you can understand how they break, and you can understand how to prevent them from breaking.
That's right.
Yeah, containers are made of Linux primitives. It's just Linux attacks, and that's important to know. Containers, I assume many of you are somewhat familiar with, but we want to cover a little bit just to kind of cover this, because containers aren't new tech. They're really just made of Linux primitives. They're C groups, they're namespaces, and they're process isolation. And the same attack surface that applies to Linux applies to containers in general. Because containers are a single process on a shared host, sharing resources often with each other and with their hosts and underlying nodes, a kernel attack surface in a single container or on that host is a shared kernel attack surface. And so container security is a holistic thing. It's only as secure as the individual container, as the applications that are running on it, as the underlying node, as the host, as the OS, as the silicon. And so it's important to think about that holistically when you're trying to secure it to make sure that all of those layers are actually being secured. And as an attacker, it means that I have a wide multivariate attack surface. It means that if I can attack that kernel, if I can attack the application in that container, if I can attack anything along that stack, I get access to a lot of it. People are doing really interesting work with container isolation right now that I want to acknowledge. But if you're not doing that, it's important to know what kinds of access somebody can get if they compromise that container or that cluster. Because shared resources make for a shared attack surface. This is a diagram about containers. And I don't actually know how we're doing on time if we need to go all the way through it. But this is how they work in relation to the underlying Linux that powers them. And I'm going to let Duffie talk.
Yeah. So as Ian pointed out, containers are basically just process isolation. If you take nothing away from this talk, other than that, that's enough, right? When we actually think about orchestrating containers, really what we're just doing is putting a process on a server, and we're associating that process with these sets of primitives. So that's the important part here, right? We can give it its own file system, we can give it its own network, we can give it its own, we can constrain how much memory, CPU, and that sort of stuff that it uses, but really what we're constraining and all of the thing we're working is just that process level stuff.
So to demonstrate this a little bit, this is a single tweet that allows us to get root on the underlying node, not using host path. So we're going to go through this because it's interesting and it illustrates some things about how you can interact with and also attack containers on the underlying, if you understand the low levels of them.
That's right.
So we're going to get root via NSEnter here.
Yeah. So let's take a look at this manifest. This manifest is actually just generated basically from that same one tweet line, just a little easier to read. And it's a very simple one. Again, I'm doing a direct target. I'm targeting a particular node name. I have specified host PID true, and what that allows me to do is when you're inside of the container's context and you type ps-ef, you'll see all of the processes of the host. I'm also giving privileged access, which is like God mode for these processes, right? Like if you have privileged access, that means that you have the ability to interact with pretty much any system call that is available to you inside the Linux kernel, all of it. And I'm just an authenticated user here. Like in the absence of admission control, there's nothing that you can do that keeps a user from being able to exercise this. This is not a magic thing. Might be fun to operate this on your own cluster and see what that looks like. So let's go ahead and deploy this thing. And if I jump in, I wanted to kind of give you a quick view into the tool that I'm using to do some of this work. This tool is called NSEnter, and you can think of it like a Swiss Army knife for all of those namespaces that comprise that isolation model for processes that we talked about, right? So you can see the list here on the left, and it looks very similar to the list that that represents all of those processes, and we're going to show that here in a second for any given process within the Linux kernel. It gives you the ability to enter into any one of those namespaces, and I've used it to actually solve kind of some mysteries around how containers are actually operating. So in my example, I'm going to go ahead and pull the PID of an Nginx process. We can jump in. We can identify, once we've identified that PID, I can use NSEnter to enter into the network namespace associated with that process and do a list of listening sockets, right? And so I could see in my case, I was trying to figure out why this host wasn't, or why this container wasn't listening on port 443, and it looks like it's just not configured to, right? It's only listening on port 80.
So as an attacker, we can do other things with this. As an attacker, if I'm trying to get into somebody's container and they don't put shell access in the container, which is common, that makes my job much more annoying because I would really like to exec into that container and see what's going on and be able to interact with it, and then I have to figure out how to do that. NSEnter, as it turns out, is one way to do that. You can just interact with that container even if it doesn't give you shell access, and if it has something like host PID, then we can interact with that process on the underlying node. Because of the way that Linux treats a file system, everything is a file, you can interact with that file system in interesting ways.
Yep.
So yeah, we did that, and this allows us, if we exec that kubectl manifest that he made, it just allows us to get root immediately on the underlying node by way of being able to interact with that PID.
And the output here on the bottom of the screen, I just wanted to point out, like if you're looking for a way to visualize what a container is, this output describes what a container is. So all of those namespaces that are associated with this particular process ID are actually going to be unique on each container. Like some of them will be common, but most of them will be unique. And that was part of the point of like what I wanted to show off here. So
yeah. This kind of thing can help you understand how containers work, which, as we said, is really important. As a pen tester, I feel like I really leveled up a lot in terms of being able to attack clusters and containers in Kubernetes context when I understood the low levels better. Because the better you know how that works, the better you know where the rough edges are. And those rough edges are where the attack surface often lives. So we're going to do this. We can take it over. And just like that, we're root.
So that gives us the ability to enter all the namespaces of the first process, the init process, and that gives us complete access over the host.
Whoa,
Sorry.
Did you just do that?
I did.
Okay. All right, so what are we taking away here? Restrict use of privileged containers. It's very common, you'll see it in every tutorial in existence, to run docker -- privileged. Doing that allows all kinds of access for you, but also all kinds of access for an attacker, and you don't necessarily want that. You want to restrict the use of host PID as well as host path in your admission control setup because that's an issue too. So is host network. And also NSEnter, really cool, and it allows you to enter any process on the underlying node. So can we fix this? Yes, mostly. And the way that we have to fix this is by use of admission control, which is basically the only line of defense against a lot of the stuff that we've demonstrated here today. It lets you limit what a user or controller can do in depth. You get a lot of granular control over it. And admission control can be validating or mutating. Real quick, I want to note that mutating admission control is really interesting as an attack surface, much in the same way that LD preload is. Because if you can turn anything into anything, with the imagination of attacker, you could potentially be able to make a legitimate process turn into something that can be used for, I can turn it into something that can be used for my purposes, that would maybe display unexpected behavior. And there's lots of valid use cases for mutating admission control, but it can present some pretty interesting opportunities. We don't have time to cover them today, but take a look at them. I think we're going to skip the demo about pod security policies, but rest to say, there was a pod security policy on, and I tried to do the same attack that we did earlier, and it didn't work because I was forbidden from doing it. So put on your pod security policies. It's important. The UX is not always as easy as it could be, and we see that, and we validate it, so to speak, but it's still really important to do.
Yeah. There is actually, this content is available if you would like to work through it yourself.
Go back. Go back.
Oh, sorry, I thought you wanted to move by it.
Well, yeah, let me drive. Okay, but there is one thing about admission control, though, which is that it doesn't actually work in relation to static pods. Because of the way that pod priorities are set, static pods actually go into effect before admission control takes into effect. So because Kubernetes is a loosely coupled distributed system, you can schedule directly onto the underlying node without use of the controller, like manager or scheduler at all. And if you are able to directly schedule a static pod, that actually bypasses admission control entirely. So admission control doesn't fix everything. And static pods are an interesting attack surface that we also don't have time to cover today. So it's important to be aware of that. But really, it is the best line of defense. So it's really important to do, and it's important to do well, because it can be hard to configure. There's a lot of moving parts, and it can be easy to misconfigure. So we know that's real, but it's also really important. So coming full circle, we're really not trying to scare you here. It is possible to secure Kubernetes clusters, at least a lot, but it's not going to happen that way out of the box. It's going to take some work on your part. That work won't always be easy. And we should not assume that Kubernetes is going to be secure by default without doing that work, because it's not. And if we assume that it is, we are leaving wide open paths for an attacker to happily travel down. And that's going to be happy for the attacker, but not necessarily happy for you. Kubernetes is powerful. It's complex. It's got a lot of moving parts and a lot of things that need configuration and can be easy to misconfigure. The attack surface is wide and varied. As an attacker, I love this. It's like an orchard. I just have all kinds of fruit I can run around picking. As a defender, that can make it really complicated, but it's still really important to do, because otherwise I have free reign of your orchard and I'm eating all of your apples. So it is possible, but we do need your help to do that. And how can we do that? Since we're here at a thing where everybody is presumably interested in contributing, let's talk about that. So if you aren't already contributing to the Kubernetes project, we'd really like to encourage you to, especially if you're security-minded and know how to think like an attacker, because I think the project needs a lot of help with that. And not necessarily just in SIG auth or SIG security. Security-minded people need to be involved in all the SIGs across all the levels of the stack, because we all need to be looking at the project in that way. And you're going to hear me say this again in a couple of days. But and Kubernetes security posture has been improving over time. There is a bug bounty coming up. There was a security audit that happened this summer that put out some really interesting deliverables and a threat model, and that's worth taking a look at and reading.
Yep.
So again, here's your takeaways. Check your assumptions. Kubernetes, not secure by default. If you understand well, though, how it works, you can understand it better as an admin or an operator, and you can understand it better as an attacker. You can understand if you understand the attack surface, you can also understand how to prevent those kinds of attacks. And yeah, it is possible to make this project more secure and to make your clusters more secure. So put admission control on your clusters and come get involved and contribute in the project. And that's what we've got. Thank you all very much.
Thank you very much.